Have you ever been puzzled by code that compiles without errors, leaving you wondering if it's a bug or just how it's supposed to work? If that sounds familiar, you're in the right place. Today, we're diving into a common question about parametric types in programming. I totally get it. It can be incredibly frustrating when you see code that seems off, yet it runs perfectly fine. You're not alone in this confusion. Many developers have faced similar situations, and it's a topic worth exploring. Here's the specific situation we're looking at. One user recently asked, "Why does my code compile without enforcing parametric types?" They provided examples like using a generic list without specifying a type. Sound familiar? Let's dig into this together and find some clarity. So what could be happening here? In some programming languages, the compiler allows certain flexibility with types, which can lead to confusion. We'll break down the examples provided to understand why this is the case. And stick around. At the end, I'll share a key insight that will help you reason about type enforcement in your code. To understand why the code compiles without errors, the user should first recognize that in some programming languages, type parameters are optional. This means that the compiler allows certain types to be inferred. Next, the user should consider the implications of using a type alias without specifying a parameter. For example, when defining a type alias for a list, the compiler assumes a generic list type. Now let's look at the custom union types. The user can define a state type that accepts any value, which is why the code compiles without errors even when a specific type is not provided. Additionally, when defining functions, the user can also see that omitting the type parameter leads to a generic function. This is another instance of type inference at work. Finally, to reason about this behavior, the user should explore the language's documentation on type inference and type safety. This will provide a deeper understanding of when and why these patterns are allowed. Fun fact: some programming languages are designed to be flexible with types to allow for rapid development. This can be both a blessing and a curse. Now, let's look at the answers provided by other users. The user explains that defining a type alias like foo as list is acceptable, but it doesn't compile in Elm.118. They note that type aliases aren't fully checked upon declaration, which can lead to unusable aliases. They suggest that the compiler could be improved to handle this better. Interestingly, changing the alias to foo a as list a allows it to compile correctly, highlighting a potential bug in the current version. Here's the key insight I promised. Understanding the flexibility of your programming language's type system can help you reason about when to enforce types and when to allow flexibility. And there you have it. You should now have a clearer understanding of why certain code compiles without enforcing parametric types. Remember, exploring these nuances can enhance your coding skills. If you found this helpful, hit that subscribe button for more insights.